So good morning, my students. This is your teacher, Daddy Course. This morning we'll be talking about hardness of water. What does it mean for water to be hard? When do you say water is hard? Is it when you touch it and it's very hard like stone? Or you touch it and it's soft like pillow? That is not what we mean by hardness at all. Hardness of water in chemistry has to do with the effect of water on soap. There are some water that you are going to wash using soap that foam will not come out of the water at all. Those kind of water are called hard water. But when you wash with soap and foam ladder comes out easily, that is a soft water. So it is not what you think that water is hard. It is what chemists think that water is hard. So it has to do with the effect of water on soap. What do we mean by hardness of water? According to Waec, a water is said to be hard when the water does not lather readily with soap. A water is said to be hard when it does not form lather readily with soap. That is, when foam does not form easily, then you say that the water is hard. A soft water must form foam almost immediately when you use it to wash. But if the water is hard, it will not form lather, it will not form foam readily. Example of water that don't normally form foam readily with soap are river water, lake water, stream water, and sea water. You are going to know the reason why these sources of water does not easily lather with soap. That is why they are very hard. But if the water lathers readily with soap, that water will be called soft water. Example of soft water are rainwater and tap water. Now, what causes hardness of water? Hardness of water is caused by the presence of calcium ion. When calcium ion is present inside water, or magnesium ion is present inside water, or iron 2 ion is present inside water. This is iron 2 ion, Fe2 plus. Fe2 plus is iron 2 ion. So the presence of these forms of ion usually causes water not to lather readily with soap. That is, usually makes water to become hard. This calcium ion can enter into water in form of calcium hydrogen triisocarbonate 4, which some people call calcium bicarbonate, or it can enter into water through this compound, calcium tetraoxosulfate 6. Some guys like to call it calcium sulfate. Now, it is those two compounds that introduces calcium ion into water majorly. Magnesium ion, on the other hand, can be introduced into water through these two compounds also, magnesium hydrogen triisocarbonate 4 or magnesium tetraoxosulfate 6. So those two compounds can introduce magnesium ion into water. Then iron 2 ion normally enter into water from iron 2 chloride. So if any or at least one of these ion is present inside water, that water will not lather with soap. That water will not form foam. That foam you normally see when you are washing clothes and you'll be happy and the foam will be bouncing. It will not be available when there's calcium ion or magnesium ion or iron 2 ion inside that water, which means that water is hard. It means that water is hard. Now, the question is this: what causes hardness? I've already explained that. What causes hardness? Hardness is caused by the presence of the following compound. Number one, calcium hydrogen triazocarbonate 4. Remember, it has calcium, so it introduces calcium ion. Number two, magnesium hydrogen triazocarbonate 4. This one, some people call it magnesium bicarbonate. Number three, okay, what do you think that this compound can introduce? Magnesium ion, isn't it? Number three, calcium sulfate. That's calcium tetrasulfate 6 and sulfate. So calcium can enter into the solution from here. Then number 4, magnesium sulfate. So these are the sources of calcium and magnesium ion inside water. Now, ion 2 can enter into water from this compound, FeCl2. It's called iron 2 chloride. Iron 2 chloride. So whenever any of these compound is present inside your water, bros, the water will be hard though. As in, seriously, you'll be washing clothes like this, you will not see foam. You become frustrated at times because the water is not bringing out soap. As chemists, you should no longer be frustrated because you already know what causes it: calcium ion, magnesium ion, or iron 2 ion inside that water. Now, why does hard water, why does it waste soap? Why is it that hard water normally wastes soap? For you to know why hard water wastes soap, you should understand the chemistry of soap. Soap is a chemical. Ordinary soap that we use to wash, all those B29, all those Wow key soap. Now, I'm not talking about detergent. Soap in chemistry, soap and detergent are not the same. So that key soap is normally called soap. So those soap are actually sodium octadecanoate. Sodium octadecanoate. Now that's a big English. Sorry, not even English. What do we do in chemistry? That's a big word, right? But you should not be bothered about how big the word is. Octa means 8, right? Deca means 10. 10 plus 8 is what? 18. Meaning that a soap contains 18 carbon atoms. That's the meaning. And it's a sort of sodium. So, ordinary soap is sodium octadecanoate. And this sodium octadecanoate is soluble in water. It will dissolve inside water. But if the water that you want to use already contains calcium ion or magnesium ion in form of those compounds that we have talked about, then it will become difficult for the soap to dissolve in water and form lather. Now, what happened? Why is it difficult for the soap to form lather with water when there is calcium ion inside it? When you put the soap inside water, this is the soap. When you put it inside water, it will react with this calcium sulfate, this compound. And then the sodium that is there will be replaced with calcium. Are we together? And form calcium octadecanoate. See, 17 carbon plus 1 carbon, right? Making 18 carbon. That's why it's called octadecanoate. So this will form calcium octadecanoate. This calcium octadecanoate is insoluble in water. It doesn't dissolve inside water. That is why you will see that sometimes when you are washing clothes, it doesn't produce foam. It brings out scum. All this insoluble precipitate, all this insoluble irritating solid like that, it just spread on the water and it will even be sticking to clothes. It will not, it will be attaching itself to clothes. It will not go easily. That compound, that substance that is there is calcium octadecanoate. It's an insoluble compound. It is formed because the water is hard. That is because the water contains calcium ion or magnesium ion inside it. That is why you are having that unpleasant solid called scum. SCUM, scum. So that is why. So if a water contains calcium ion, you will use the soap to continue to remove the calcium ion until all the calcium ion is removed before you can now start having foam. As long as there's still calcium ion or there's magnesium ion inside that particular water, you will never get lather. So the water will be wasting your soap. Instead of it forming lather, it will be reacting with the calcium ion and be forming insoluble scum. Insoluble scum. So you have to use your soap to remove all the calcium ion before you will now start using extra soap to now do the real washing. That's why hard water normally wastes soap. That's why it normally wastes soap. Whenever there's calcium ion or magnesium ion inside that water, this is the result that you normally get. So I said because you need a large amount of soap to precipitate or remove that calcium ion. After you have removed the calcium ion with large amount of soap, then you will now use more soap to do the actual washing. You can see why hard water wastes soap. It actually wastes soap. So, but what can we do? So it wastes soap. But what can we do? That's why we develop other forms of washing clothes by using detergent. Detergent doesn't form scum at all with water, because detergent is not normal key soap. It has a different chemical formula from a key soap. So a detergent, if you use it to wash in what do you call it now? If you use it to wash with hard water, it will still react with the calcium ion, but the product that will be formed will be soluble in water. So scum will not be formed. Instead, lather will be formed readily. So this is why some people prefer detergent to soap for washing. But we all know that detergent sometimes can spoil your clothes, especially if it's a colored cloth, because it's stronger than a normal soap. So nevertheless, detergents overcome this problem of hardness of water because its own compound that it forms with the calcium ion of the water or the magnesium ion of the water, that compound is soluble in water, unlike soap that forms a compound with water that is insoluble inside the water. That is why soap normally doesn't form lather readily with hard water, but detergent forms lather readily with hard water. Now, the question before us will be this: how does water acquire hardness? How does water become hard? What makes water to be hard? Does water become hard from heaven, where it is coming from, or does it acquire the hardness on its journey to the stream or on its journey to the river? Actually, rainwater doesn't have iron, so it's not hard. But when rain falls and the water begin to flow, if the water flows on a soil that contains gypsum, gypsum is a calcium sulfate, hydrated calcium sulfate. You can see calcium sulfate 7 of water, that's gypsum. So if a water contains if the water flows on soil that contains gypsum, or it flows on soil that contains limestone. Remember that limestone also contains calcium. You can see that. So this water can dissolve the gypsum, that is acquire the calcium ion inside, or dissolve the limestone from the soil over which they are flowing. Now, there's something I want you to know. Gypsum itself is not particularly soluble in water, but it's sparingly soluble. That is, only few of the calcium sulfate 7 of water will dissolve in water. Now, if this sparingly soluble calcium sulfate does dissolve a little bit, there will be calcium ion in the water. Limestone does not dissolve at all inside water. Remember that the solubility rule, that all carbonate salts are insoluble except their sparse salt, that is, except their sodium, potassium, or ammonium salts. That is, sodium carbonate is soluble, ammonium carbonate is soluble, then potassium carbonate is also soluble, but no other carbonate salt is soluble in water, meaning that calcium carbonate, that's limestone, does not dissolve inside water. But how does Caco3, this limestone, how does it enter into water whenever the water is flowing on the soil? Now, pay attention. Calcium carbonate doesn't dissolve in ordinary water. But if that water already contains dissolved carbon dioxide, if there's carbon dioxide inside the water, like we see in this place now, there is ability of the water to dissolve calcium carbonate and form this compound. Do you remember this compound? It's a salt. What type of salt? Don't forget, it's an acid salt. Can you see there's hydrogen? There's a replaceable hydrogen there. So it's an acid salt. See. So there's a replaceable hydrogen there. So it's an acid salt. So the thing will dissolve in form of this compound. And remember that this compound is the one that is responsible for carrying calcium into water. I gave you two compounds from which calcium ion can enter into water. I gave you calcium hydrogen trisulcarbonate for this compound. And I also gave you calcium tetrasulfate 6, that's calcium sulfate, which is that gypsum. So whenever these two compounds are present in the water is going to be hard, very hard, very, 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 very hard. So that is how water acquires hardness. Whenever it flows over a soil that contains gypsum or that contains limestone, then it can dissolve those compounds and acquire or obtain calcium ion, which makes water to be hard. I hope you understand that. So this is how water acquire hardness. So in my next video, I'm going to discuss with you two types of hardness. We have temporary hardness and we have permanent hardness. I will tell you why we call it temporary and why it is called permanent. So but for this class, I want to say goodbye, and I hope you understand what we have discussed very, very well. So we'll meet in our next class. God bless you.